Hello, for data communications and network one class today. Just like we talked about the IP address, okay, Internet Protocol address. The number of Internet users worldwide as of April 2024 is 5.44 billion, okay, user. It's about 67.1% of the global population. So everyone is using Internet, and I believe you have the Internet, right? In order to access my YouTube video, you must have an Internet device that can access the Internet, right? There are two versions of the IP protocols, okay? The first version is version 4. The second is version 6, okay? And this is replacing the version 4. The problem, okay, of the version 4 is that because many people are using the internet, and the inventor of the internet didn't foresee this, okay, that everyone will use the internet, okay. So the address is not enough to support everyone, okay. So we have to increase, okay, the length of the address, okay, of the source address and the destination address, okay, to make sure that it can cover every users, okay. So this is the main reason for changing from version 4 to version 6, okay, and they are trying to change for decades now, but right now, as of August 14, okay, 2024, the version 4 is still more used than version 6, okay, although it is getting closer. The version 4 is using like 50 something percent, and version 6 is 40 something percent, okay. So now it's replacing, but you still have to learn version 4 as it still dominate the internet, okay. For Kasetsart University, there are both version 4 and version 6 if you access the internet, okay, in the KU-WIN network, okay, you can read that they have version 4 address and version 6 address, okay, because version 4 have not enough address, okay, so we have to increase not enough address, okay, for all users, okay. And this is a statistic, okay, of the IPv6 adoption from Google. This is August 14, 2024. You can check the statistic, every day they update, every day, okay. So you can see that this is 50%, right? So 50% is here. So right now, it's still less than 50% that use IPv6, okay. 2010 is about 0% that use IPv6, okay, and it's increasing like this. Now let's look at the IPv4 header. The IPv4 datagram, okay, consists of the header and the data. You have 20 to 60 byte long, okay, minimum of 20 byte for the header, and total, total has 20 to 65,535 bytes maximum, okay, for one datagram. And this is the header of the IPv4, okay, from the wiki, okay. Version is version 4. Total for one row is 32 bits, okay, here. So you have IHL is the header length, okay. TLS is a type of service. The header length is up to 60 byte, okay. This is optional header, but usually we are not use much, okay. Usually we use 20 byte, okay, as the basic header. The type of service is kind of like the quality of service. If you want to differentiate, you want to like kind of service some data link connection from A to B, okay, maybe have like higher speed or higher priority, okay, you can specify here. And then you have the total length, which is the length of header plus data, okay, so up to 65,535 bytes, okay. Identification is like ID, okay, to uniquely identify the datagram, okay. We have the fragmentation offset or fragment offset, which I will talk about in the next slide. We also have like some more details like the flag. You can read about this, okay, in the you can search Google, and it's also in the wiki, okay, if you want to know more in detail, okay. I will try to focus on the main field, okay. The time to leave, okay, is like to prevent the datagram from staying indefinitely, because if the datagram, there's something wrong with the datagram, it does not arrive to the destination, sometimes it will go around and round and round, okay. So you have time to leave, so when you exceed the time to leave, it will be dropped, okay, so that it will not just be like junk inside of the internet, okay. Protocol, you have a header checksum. This is check only header. This is like the parity check bits, okay, that we have studied before, the error correcting code, okay. But check only header. We have source address, okay, 32 bits, okay, source address, and 32 bits for destination address, okay, and this is data to this much. Now let's look at the fragmentation offset, okay, in the IPv4 header. If a datagram is fragmented, okay, you can see that it can have the size of up to 65,000 something bytes, okay, very long. So when you go through many different networks, okay, that support shorter packet size, okay, you may have to fragment. So if this is your datagram and you have to fragment, okay, them, okay, right? So you fragment, and then you add, you must add header. The same header you have to add, okay, for every fragment, okay. So it's small unit, you have the IP header of minimum 20 bytes, okay. All unit will have the same ID but different fragmentation offset. We'll see an example in a little bit, okay. And this one, the fragmentation offset will indicate, okay, where in the current datagram it belongs to. Okay. Suppose a datagram is fragmented into 2 units, okay. So this is the first unit and this is the second unit. Both of them has the same IP header, okay. This one has contain, okay, byte number 0 to byte number 3,999. The second one starts from 4,000 to 7,999, right? In this case, this one, okay, in the IP header, the ID is the same, okay, but the fragmentation offset equal to 0 here. Fragmentation offset is 0. This one, fragmentation offset is 4,000 here, okay. So ID is the same, the fragmentation offset is different, okay. And then when you arrive at the destination, you can take the header out and you can place it into the correct position, right, to reassemble into the datagram. Now let's compare to the IPv6 header. This is IPv6 header is minimum 40 byte, okay. Octet is the same as by octet, it's like 8 bits, okay. Minimum 40 byte, and then it can extend, okay. And then this is the transport level. PDU is protocol data unit, okay. And this is the version, okay, version 6. This one is kind of like the type of service, okay, in the IPv4, okay, similar to that. Mainly, okay, IPv6 header is simpler than IPv4 and longer, okay, than IPv4. Has minimum of 40 byte, okay. This is, as I say, it's like type of service in IPv4. This is basic. Actually, this one is like explicit congestion notification. The congestion we'll talk about later, okay, in class. Later, after we finish the internet topic, okay. Anyway, the payload length, okay, is the length of the datagram, but not including the fixed 40 byte header. So this is the payload length. Okay, okay. They try to design the header so that it have fewer fields inside of the header. So whatever you want to put in the header for that specific application, you put it in the extension header. Okay. The next header tells, okay, which of the optional extension header follows. Okay. If this one is the last IP header, the next header field just put the transport protocol that we use, like TCP or UDP here. So if this is the last one, it's put it here, okay, in the part of the next header. For the hop limit, okay, same idea as the time to leave in the IPv6, just count the number of hop, like A to B is one hop, B to C is one hop, okay, so that it will not go round and round and round indefinitely inside of the internet, okay. After it reaches the hop limit, it will get dropped out of the network, okay. The source station address 128 bits, okay. This is the main thing that we have to do. That's why we have to change from version 4 to version 6, okay. Because version 4 use only 32 bits and we have 5 point something billions user, okay, so not enough anymore. And so that's it, okay, for the IP address introduction. Okay, we will look at the detail on the IP address in the next clip video. Thank you.